Okay, 2.5, implicit differentiation. So first we need to identify the difference between what we have been doing and what we will be doing. So implicit differentiation would have to be performed here. Explicit would have to be performed here. So what's the difference between the two equations? This is xy equals 1, and this is y equals 1 over x, or x to the negative 2.
Divided by x and
Okay? So, but, yes, I did divide by x, but what...
they're the same thing.
Not really.
Okay, but they're not.
Without dividing by x, what's the difference between the two? What's the difference between this one and this one? You kind of were on there.
Okay.
You're kind of on the right track. Don't look at me, Natalie. Look at the board.
Still wrong. I was hoping you'd make it make sense.
Well, I'm asking for an observation. Kale gave 1. Yes, it's true.
1's set equal to y.
1 is set equal to y, correct? Okay, so we don't know how to deal with this, but we do know how to deal with this. You take dy, actually, I will step through the process of what you actually have been doing. You have y equals x to the negative 1, yes? So what we've been actually doing is doing d dx of y equals d dx of x minus 1. Yes? Okay, so we're taking the derivative of both sides. Hence, what would be dx times y? It'd be dy dx, wouldn't it? Okay, so we would write dy dx as our answer, because what we are saying is the derivative of y with respect to x. So the variable that we are differentiating is always in the denominator, in the bottom, in the denominator. Okay? So when it is difficult to solve for y, because I can solve for y easily, can't I? Here. From here to here, that was pretty easy, right? I could do that. So I wouldn't use implicit differentiation. But when it's difficult to do it, we have to be able to. So the difference between differentiating between just x, so I have d dx of x cubed. My variables agree. This variable and this variable agree, correct? We're differentiating with respect to x. But on the next one, it does not agree. I have d dx of y cubed. So they don't agree. So how we do that is we just took the derivative of y. Do you see that? It's normal differentiation. But then behind it, you have to find the derivative. You just have to write dy dx. Because we identify this as u and the inside. So this picture, to me, extremely overestimates or overcomplicates what is going on. Now, what if I wrote d dy of y cubed?
Well, then it'd just be
It'd be the 3y.
squared.
Right, it'd just be the 3y squared. And that's because why?
Because
They agree. So, question for you. What about d dy of x cubed?
And then you have to do
You
that. You
have
have to put the
dx dy of 3x squared.
So 3x squared
to the
dx
over
dy times dx dy. Okay?
That one says, oh, because you have opposite.
Because I have opposite, yes. So we have to pay attention to that variable in the denominator, right? Okay. So let's do a couple examples. So I want the derivative of y with respect to x. Oops, sorry, I got a spot on here and it jumped.
Those look like they get kind of weird.
And There's a lot going on here.
Okay, just write the problem. Why is it jumping?
Hey, this is, can I fix something real quick?
What? Did you put something wrong? I did not do that.
Good thing you teach math, not English.
Okay, so dy dx of x plus 3y. So I'm going to do it, just approach it like it's a normal problem. I'm taking the derivative with respect to what? X. Oh my gosh. Okay, so what am I going to get?
You're gonna get
1 plus 3,
1.
4. No, but with y.
So dy dx is going to equal 1 plus 3, but what do I have to put after it? Dy dx.
No,
Because the y
Because of the y.
alive. So you're going off of the denominator. is the
Yes.
one that
The
you're-
denominator is the variable you are differentiating with respect to.
And then the one that is not. So if they flip it, then it would be the opposite.
Mhm.
But that was the one.
Mm-hmm.
But you still do both of them just like you
Yes.
regularly would. Okay.
Okay, so how am I going to take the derivative of the next one?
That's what you're supposed to tell them.
With respect to x, but am I going to have to use a certain rule?
you're going to have to multiply.
So that's called the product rule.
Maybe I can't remember.
So-
We've never named a single rule in this classroom. I don't know what you want us to say. I don't get why mine didn't do the job.
So dy dx of, so it's the derivative of the first, right? Times the second. Plus the first times the derivative of the second, which will be
What do you want?
Y dx squared.
2y dy dx. Quit trying to make this hard. Wait. Now that looks pretty yucky, yeah? What's wrong, Natalie?
So at the beginning, there's a 1y squared.
Right, but we took, remember it's f prime g,
Oh, so there
and then g prime f. So I'm not taking the derivative of y squared on the first.
You're just adding it. So
I'm
only
just-
if you're taking the derivative.
Yep,
you have to-
only if you're taking the derivative.
Okay.
Okay, so there's like, to me, there's too many dy dx's. Yes? How about you?
Well, I
Only
mean, there's
one
2 of them.
DY.
Well, no, there's two of them.
Oh.
There's one here and one here. So I have dy dx equals y squared. I'm just cleaning it up a little bit. Plus 2xy dy dx. Correct?
Sure.
What if I told you I only want one dy dx, not two?
You just
Well,
erase
then,
one.
yeah.
That doesn't work.
There's 2 in the first one.
Yeah.
I only want one now. We can start with the first one.
No.
Something you're going to have to do every time.
So now, to get rid of that, can you just switch it and put it? No.
Okay, so when we're solving for anything, a variable, we put all the variables on one side, yes?
Yeah.
So let's start with this dy dx, or do you guys not have room to add on to this
I
one?
have plenty of room.
I definitely do too.
Huh? You're good? Okay. So we need to move the dy dx's on one side, yes?
So just
How would I do
divide
that?
by dy dx.
Say that again?
Divide by dy dx.
Subtract.
Subtract,
Loser.
because there's a 3 with it, and it's not multiplication with the 1.
Okay.
So I have dy dx minus 3 dy dx equals 1.
So would it just be negative 2 dy dx?
I got 2, I want 1.
No. This,
Negative 2 dy.
What can I do with a dy dx?
Like terms,
cross
you can
them out.
combine them.
Can I factor out a dy dx?
Yes.
If I factored out a dy dx, I would have what? 1 minus. Oh, I could have just combined those.
That's what I said, and you're
That's what
saying.
I'm sorry, Kale.
I said that.
Kale, what do you get?
Negative 2 dy dx.
And that's why I did this one first. I'm sorry, guys.
I said that.
Okay, now what?
Now.
You
divide
all
by
said it. I didn't.
Negative 2.
So divide by negative 2. So dy dx equals negative 1/2.
Yeah.
Okay. So now what am I going to do on this one?
This one you'll have to factor in. Once you get it all arranged properly.
So we're going to bring all the dy dx's over to the left.
Yeah.
I think my brain was still stuck on this one. This is why I want to do the other one first. So it equals y squared, right? Now do I have to factor out the dy dx? So dy dx times one minus 2xy equals y squared. So dy dx equals
1 squared root of 1 minus 2x.
Now, technically, I wasn't supposed to do that with these because of the way they're written, but there's no point of making it sound like we're not going to do this, okay? So the way they're written right here like this, it's not an equation, is it?
No.
It's just an expression. So this is our answer. What I did is I made an equation right here, didn't I?
You did.
Okay, so most of the time we won't be solving things like that. So what we will be doing for guidelines for implicit differentiation. Ooh, I don't like that there are X's in here.
I don't like you. Just kidding.
That was really rude.
You love kill back.
Okay, so differentiate both sides of the equation with respect to X. So if you start off with an equation, you need to differentiate both sides of the equation.
Should we write these down?
And that's up to you. So what we just did, basically.
Yeah, let me write.
You need to collect. You might not want to put all those words because those are exactly what the book has.
Collect them.
I would say move the dy dx to the left and everything else to the right.
Collect them all.
Okay, so collect all the terms involving dy dx on the left side of the equation and move all other terms to the right side of the equation. Honestly, do they have to be to the left and have to be to the right?
Yes.
No. You just have to move them, right? Factor the dy dx out of the left side of the equation and solve for dy dx. Is that exactly what we did?
You.
Yeah. To the left and to the right.
To the left, to the left, to the right. Okay, so when is our test?
Next week.
Wednesday.
Wednesday.
I thought you said it was next week.
Next
week,
Wednesday.
Oh, silly goose.
Sorry.
While you guys are writing, I will let you know on Tuesday, you will be taking your Probe 1. Everybody will be eating lunch, first lunch.
You should bring us lunch.
Yo, let's all get
You should buy us a
Subway.
pizza
or pizza.
for making us take this.
It's torturous, really. I mean, we could be preparing for a test. What hour did you say that is? Or just
Fifth.
our class? Fifth. What do I have? Gets me in the barn hearts. Like,
Natalie,
what?
I'm recording.
Because I have.
Are you done writing yet?
Is Mrs. Barnhart gonna watch this?
Are you done writing yet, Natalie?
No, you got distracted with the probing. Okay.
Yikes.
I don't know. I have a whole thing packed up.
Okay, so find dy dx. So our rule said did what? Do what first?
To differentiate both sides
I
of
didn't
the
write it down.
equation with respect to x.
So we're going to do dy dx of y cubed plus y squared minus 5y minus x squared equals dy dx of -4. Yes?
I suppose.
Okay. So, go.
Go to bed.
I got the right. 0.
Go away.
I did my part. You guys done with yours yet?
No.
Oh, okay.
I did that too. I'm gonna get annoyed with writing dy dx.
And you will start doing them like all in your head. Okay, so you have 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x
Yeah.
Equals 0.
equals 0. Yes? So then it said move, right? So watch this. Equals.
True.
Yes?
Yeah.
I usually move to the one side and factor all in one. Does that make sense? You guys are probably rewriting it, aren't you?
Yeah, for sure.
I did not rewrite it.
Okay. I will tell you, this is what I typically do. I'll show you. I will typically move to the right and factor out all at one time.
Yeah.
Actually, and I usually factor out in the back. I put dy dx in the back.
And then
And so I would have 3y squared plus 2y minus 5. And so dy dx equals,
2x times.
how about divided by?
I was gonna say times the reciprocal of it. I swear.
I so believe you.
Aw, thanks.
So basically what we did on the other one, right?
I suppose.
That's it. Ready for another one?
Is this what our homework's on plan?
We got to do slope and equations.
Can we just stick to the easy stuff for once?
Okay, find the slope. Well, how do I find the slope of a tangent line? I first have to find the what? Derivative. So we're going to take dy dx of x squared plus 4y squared equals dy dx of 4. I get the right side again. 0.
Because you're gonna do both sides anyway.
I know. I figured I'd give you guys a head start. Just keep going and tell me what you get for dy dx. Did you guys get negative x over 4y?
If I could multiply, right? I did take 4 times 2 and get 2.
And got 2?
Yeah.
I could understand 6, but not 2. Natalie, did you get that? Are you on your way to get that?
I'm on my way to getting that. I'm just slower than the average Joe.
Joe who?
So now I need to find the slope, yes? So M sub t? What's M sub t stand for?
Slope of t.
Slope of the tangent line.
Fine.
Well, I have an x and a y this time. But look what they gave me. An x and a y, yes?
Yay.
So negative square root of 2 over 4 times negative 1 over the square root of 2.
Icky.
Oh, no. We just multiply by the reciprocal of 1 over the square root of 2, right? So we just multiply by negative square root of 2. So negative square root of 2 times negative square root of 2 is 2 over 4. So we get what?
1,
See, it wasn't that bad, was it? Okay, next.
No. I'm just kidding.
I think. Oh, try this one on your own. Ooh, this is gonna be fun. I think you got a chain rule involved in there. What do you think? I think you do. Oh, and a product.
And a what?
And a product.
A product. You said. Why? Not listening. Is that necessary? Mhm.
Three squared's 9. 9 times 12 is 108, right? I was like, wait a second. So it'd be 120.
Volleyball girls are
So
dismissed.
180.
High school volleyball girls are dismissed. They need Haley Barton to stop by the office first. Haley Barton, please stop by the office.
Right? 108 plus 12 minus 300. So 120. So 180.
I'm not yet.
So then 13 over 9.
I'll take your word for it.
Did you get the derivative right?
Eventually. Some,
That was a little harder, wasn't it?
Yeah.
yeah.
So when you got here, you had to simplify. When you got right here, you had to simplify, right? But I couldn't just move things over. I had to distribute this out, didn't I?
Yeah.
Yeah.
I didn't do that until I looked up and saw you doing that, and then I was fine.
Now, why should you have known you had to distribute first?
Well, because
Because it's
have to.
right. Well, you could divide by this, but your problem then is you'd be stuck with this in a division problem, which can happen, right? Okay. So, took a little bit more time, but is it doable? Yes.
We just did it now.
What does this one mean?
It means find
The second derivative. So you're going to do it once and then you're going to do it twice. Okay, so now we're going to start doing shorthand, right? dy dx. And so 2x plus 2y dy dx. And equals 0. So I would subtract this over, divide by that. So dy dx equals negative x over y. So then I have to do it again. So I have dy over dx squared, meaning second derivative. And I got to use the quotient on the other side, don't I? I know I did that kind of fast because I knew I was running out of time. So what do I have? Negative 1 or negative y, right? Minus a negative x dy dx. All over y squared. So, I think I get x dy dx.
Your thingies.
It goes away. It's just calibrating. Minus y
You're just calibrating.
over y squared. But we have a problem. We have a what here?
But I did it.
A dy dx, right? Okay, but don't I have the answer right here to dy dx?
Oh,
So dy dx equals negative x over y, which equals what? Don't we have x and y? So that'd be 3/4.
yeah.
So now I have to plug in x, y, and 3/4.
Oh, it's already answered.
I'm losing my room. So x is negative 3.
You're right.
So negative 3 times dy dx, which is 3/4, minus 4 over 16. I have to go backwards. Sorry, guys. So negative 9/4 minus 16/4, all times 1/16. So negative 25 times 16. Eight goes into both, right? I get negative 3/8. Okay. So it said evaluate, but are we still just finding the slope? Yeah. So when we get done, we have to go back to our first derivative to find our information. And we got through all the notes. So start on your homework tonight,
No.
and then we can finish up tomorrow with questions and stuff.